The universe is not just expanding. It is expanding faster and faster, every galaxy racing away from every other at an ever-quickening pace. Something is pushing the entire cosmos apart, overpowering all the gravity of every star and galaxy combined. We have no idea what it is. We call it dark energy. For most of the last century, we knew the universe was growing. Galaxies were sailing away from us, and the farther away they were, the faster they receded. Space itself was stretching, carrying the galaxies along like dots on an inflating balloon. That much was settled. The question was what would happen next. Everyone assumed the expansion had to be slowing down. After all, every galaxy pulls on every other through gravity, and gravity always attracts. Like a ball thrown into the air, the cosmos should be coasting outward but gradually losing speed, its own weight reining it in. The only question was how fast it was breaking. To find out, astronomers needed a cosmic measuring stick, and they found one in a special kind of exploding star. A certain type of supernova always detonates with almost exactly the same brightness. Knowing how bright they truly are, and seeing how dim they appear, reveals precisely how far away and how far back in time they lie. In 1998, two teams measured these distant supernovae, expecting to see the expansion slowing. Instead, the faraway explosions were dimmer than they should be, meaning they were farther away than a slowing universe could explain. The expansion was not breaking at all, it was speeding up. It was a stunning, almost unwelcome result. An accelerating universe meant some unknown force was pushing everything apart, working against gravity across the whole cosmos. The teams checked and rechecked, braced for an error. There was none. The acceleration was real, and physics had a vast new mystery on its hands. Whatever was causing it had to fill all of space, push outward, and grow in influence as the universe expanded. It gave off no light and clumped nowhere. With no real understanding of its nature, physicists gave it a placeholder name that has stuck ever since: dark energy. And here is the staggering part. When cosmologists add it up, dark energy makes up about 68% of the entire universe. Dark matter is another 27. Everything we can see, every star, planet, and person, is less than 5%. The cosmos is dominated by a thing we cannot identify. The leading explanation is an old one. Decades earlier, Einstein had added a term to his equations to keep the universe still, a constant energy belonging to space itself. When he learned the universe expands, he discarded it, reportedly calling it his greatest blunder. Dark energy may be that very idea, returning in triumph. In this picture, dark energy is the energy of the vacuum itself. Empty space, it turns out, may not be truly empty. Even a perfect void can carry a faint, constant energy, and that energy pushes outward. Stretch space, make more of it, and you make more dark energy, driving the expansion ever faster. But there is a deep problem. When physicists try to calculate how much energy empty space should contain, using our best theory of the quantum world, the answer is too large, not by a little, but by a factor with over 100 zeros. It is the worst prediction in the history of physics, and no one knows why. Maybe dark energy is not a constant at all. Perhaps it is a new field that fills space and slowly changes over time, a possibility physicists call quintessence. If so, its push might strengthen or fade across cosmic ages, and the fate of the universe could be very different from a simple, steady acceleration. There is another puzzle, almost philosophical. Dark energy has only recently come to dominate the cosmos. For billions of years, matter held sway and expansion slowed. Only lately did acceleration take over. That we happen to live right at this turning point feels like a strange and unexplained coincidence. Dark energy does not only show in supernovae. Its fingerprint appears in the faint ripples of the oldest light in the sky and in the vast cosmic web of galaxies. Several completely independent lines of evidence all point the same way. The acceleration is not a fluke of one method. The whole cosmos agrees. If dark energy is a true constant, the future it writes is bleak and grand. The expansion will keep accelerating forever. Galaxies beyond our local group will recede faster and faster until they cross a cosmic horizon and their light can never reach us again. One by one, they will simply vanish from the sky. Picture the deep future sky. The galaxies we see today, thousands upon thousands of them, will be gone, carried beyond reach by the relentless stretch of space. A far future astronomer might look out and see only our own merged galaxy, alone in an apparently empty void, with no clue that a wider universe ever existed. This long, cold ending has a name: the Big Freeze. Stars will burn out, galaxies will drift apart, and space will grow ever emptier and darker and colder, stretched toward a thin, lifeless stillness over spans of time that dwarf everything that has happened so far. Acceleration, carried to its quiet final conclusion. There is a darker possibility. If dark energy grows stronger with time, the acceleration could become catastrophic. First galaxies, then solar systems, then planets, and finally atoms themselves would be torn apart by the runaway stretching of space. The universe would end not with a freeze, but by ripping itself to shreds. Which fate awaits us depends entirely on the true nature of dark energy, on whether its push stays constant, fades, or grows. And that is precisely what we do not yet know. The ultimate end of the universe hangs on the identity of its most abundant and most mysterious ingredient. So we are building the tools to find out. Vast new telescopes are mapping billions of galaxies, charting precisely how the expansion has changed across cosmic history. By measuring whether dark energy has been perfectly steady or subtly shifting, we hope to finally pin down what it is and where it is taking us. And the latest surveys have dropped a tantalizing hint. Some early results suggest dark energy may not be perfectly constant after all, that its push might be slowly weakening over time. If confirmed, it would overturn the simplest picture and reshape our understanding of the cosmos and its fate. The story is far from settled. It is worth being clear about how strange this is. Dark energy is not one of the familiar forces. It does not pull like gravity or push like pressure in any ordinary sense. It is a property of space itself, a tendency for the vacuum to expand, written into the fabric of reality in a way our theories cannot yet capture. For all its mystery, dark energy governs the largest story there is. It decides how fast the universe grows, how galaxies are spread across the void, and how the whole vast structure will end. The grandest features of the cosmos are dictated by the one component we understand the least. Step back and take in the full accounting. 68% dark energy, 27% dark matter, less than 5% everything we have ever seen or touched. We have built a magnificent science on that small, bright sliver, while the vast dark majority of reality remains almost entirely unknown. Dark energy sits at the very frontier of physics, alongside the singularity and the quantum world, one of the great unanswered questions of our age. Solving it may require a revolution as deep as relativity or quantum mechanics. The thing that fills most of the universe is a door we have not yet learned how to open. There is a strange privilege in our moment. We live early enough in cosmic history that the distant galaxies are still visible, their light still reaching us before the expansion sweeps them away. We can still see the wider universe, still measure dark energy at work. Future minds may not be so lucky. In that sense, the cosmos is handing us a fleeting gift. The evidence of dark energy, written in the light of receding galaxies, will grow harder to read as those galaxies vanish. We happen to live in the brief window when the universe still shows us enough to ask the question at all. Hold the central strangeness one last time. The most powerful influence in the universe, the thing steering its entire future, may be the energy of empty space, the pressure of nothing at all, pushing the cosmos apart faster and faster forever. The void is not passive, it is in command. So when you read that the universe is accelerating, remember what that really means. An unknown something, filling all of space, is overpowering all the gravity in the cosmos and deciding how everything ends. We have measured it precisely and named it carefully, and we still cannot say what it is. Dark energy is the universe's final humbling lesson. We have mapped the heavens, weighed the galaxies, and traced cosmic history back nearly to the beginning, only to find that most of reality is a mystery we have barely begun to name. The cosmos is mostly dark, mostly unknown, and still quietly expanding. And so the universe drifts on, galaxies parting from galaxies, space swelling between them, driven by something we cannot see and do not understand. We are here briefly in the bright early age, watching it happen and asking what it is. That question, more than any answer, may be the truest map of where we stand.